So I can graph any function, especially rational ones, by using what we've learned in calculus. We're going to take limits as x approaches infinity, positive and negative, and we're going to take limits as x approaches critical points where we have asymptotes. So we'll do the first one first. Since we're looking at very big and small numbers, I could ignore the +1 and the +2, and I'm really looking at x over x squared, which simplifies to 1 over x. When we put a very large number in here like infinity, this goes to 0. So I'm going to have a horizontal asymptote on the x-axis. Next, I'll seek to find any vertical asymptotes where we know we can't divide by 0, and -2 plus 2 would force that division by 0. So I must have a vertical asymptote at x equals -2. So when I plug some numbers just left of -2 and just right of -2, but I square each of them, hopefully you can see that I'm going to get a negative number divided by a positive small number in each case. So each of these will have a limit of negative infinity. And so my graph is going to come from negative infinity up. So the next thing I'll do is look for any zeros, and that'll happen when the numerator equals 0. Well, that's pretty easy to see that we have a 0 at -1, so I'll plot that. Also, y-intercepts are easy to see because that's whenever x equals 0. So we'll put in 0 plus 1 over 0 plus 2 squared, and we'll see that when x equals 0, y is 1/4. I can put that dot in. So now I can see where this goes, through the 0, through the y-intercept, and I'm approaching 0 as x goes to infinity. Similarly, going to negative infinity, I have the same behavior, but I don't have any more zeros, so I never cross that x-axis. I just go to infinity. Here are some great challenge problems to try to be able to do. You can always check yourself on your graphing calculator or Desmos to see if you've done it right.